Hi guys, welcome to CMA solution page. In this video, we will watch job allocation assignment technique problems under the head production planning and control. So, subscribe our channel to receive more videos. Many students considers that job allocation is a very tricky and confusing illustrations, but it is not like that. If you understand it clearly, you can definitely rock it. Moving on to illustration number 2. A captain of a cricket team has to allot 5 middle batting positions to 5 batsmen. The average runs scored by each batsman at these positions are as follows. So this is table. It has batting positions and batsmen. A, B, C, D are the 5 levels. Okay. Make the assignment so that the expected total average runs scored by these batsmen are maximum. By reading this question, we have understand that it is a maximization problem and it has the word maximum. So this is a problem of maximization. To solve it using assignment technique, it has to be converted into minimization problem by forming a relative loss matrix. So copy the question. By copying the question and the boxes, we should analyze which number is higher. Okay. So in this box, 60 is the highest number. So 60 are the highest number. It has two highest numbers, that is 60 and 60. So this is the highest number in this box. So we have to put relative loss matrix by using this. Okay. Before moving to relative loss matrix, you should subscribe our channel to receive more video like this. Okay. Okay. Let's move to the relative loss matrix. In this matrix, we should do 60 minus the relative element. Okay. That is we have to subtract each element from 60. So 60 minus 40, 60 minus 40, 60 minus 35, 60 minus 25 and 60 minus 50, 60 minus 42, 60 minus 30, 60 minus 16. Okay, in this way we have to subtract all the elements. So the answer is 20, 20, 25, 35, 10, 18, 30, 44, 35, 33. Like this way we have to do it. Okay, so the highest element, from the highest element we have to subtract the elements. Okay, relative loss matrix is done by using this method. Moving on to row operation matrix. In this step we should find out which number is lower in each row. So we should find out which number is lower in each row in relative loss matrix. Okay, so we should find out which number is lower. Here in the A row we have 10 as the lower number. So we should minus 10 from 20, 20 minus 10, 10, 20 minus 10, 10, 25 minus 10, 15, 35 minus 10, 25, 10 minus 10, 0. In this way we have to minus it. Moving on to second row. Here we should have do the subtraction from the lower number. So in this row we have the lower number as 18. So 18 minus 18, 0. 13 minus 18, 12. 44 minus 18, 26. 35 minus 18, 17. 33 minus 18, 15. In this way we have to calculate this row operation matrix. We should find out the row lower number and we have to subtract it from the elements, other elements. Okay, so in this C row we have 0 as the minimum number. So we should subtract 10 minus 0, 10. 12 minus 0, 12. 20 minus 0, 20. 0 minus 0 is nothing but a 0. 10 minus 0, 10. So we should do like this. Okay. In the end of this video, you have one summary to make more easier. So don't skip and understand it clearly. The next step is we should put column operation matrix as a head. In this step, we should find out lower number in each column. Okay, so we should analyze that which one is lower in this column. The 0 is the lower one, so we should minus 10 by 0, 10 minus 0, 0 minus 0, 10 minus 0, 5 minus 0 and 2 minus 0. So the resulting answer will be the same. Okay, so put the same number in this column. Moving on to second column. In this column we should have 0 as the lower one, so minus 0 from every element. Okay, in this moving on to third column. In this column we should find out which number is lower one. So in this column 1 is the lower one, so we should minus 15 minus 1, 14, 26 minus 1, 25, 20 minus 1 19, 5 minus 1 4, and 1 minus 1 is nothing but the 0. So moving on to next column. In this column we find 0 as the lower one, so minus all elements from 0. Moving on to next column. In this column we should have 2 zeros, so 2 lower number, so we should minus each element from 0. Like this way we should do the column operation matrix. Okay, before going to next step, if you don't subscribe our channel, please subscribe it to receive more videos like this. Okay, in the coming steps we should do allocation. For allocation, 0 plays the major role. Let me see the first row. It has only 1 0, so do allocation. If you have only 1 0 in a row, do allocation. Okay, so allocate 0. After allocation, you should cut down the proportionate column, so cut this column. Okay, moving on to next row, B row. In this row we have only 1 0, so we should do allocation and cut down the respective proportionate column. Moving on to third row. In the third row we have only 1 0, so allocate this and cut down the proportionate column. Moving on to D, that is fourth row. We have only 1 0, but this 0 is already cutted, so moving on to next E row. In this E row we have 2 zeros, so in this 2 0 we don't put hands. Okay, we have to finish in this row. Next step is we should look the elements in the column wise. So we should look column wise the elements and find out if there is any 0 was present. So I copy this box for super clear for our super subscribers. In this step we should copy the already allocated elements. Moving on to next step, we should look column wise the elements. So in the first column it has already been allotted, so moving on to next column, it has only 1 0, allocate this and cut the proportionate row. Then moving on to next column, it has already cutted, so moving on to next column, it has already been allotted and this also allotted. So here we have 1 2 3 4 allocation. So this is not equal to the order of matrix. The order of matrix is 5. 1 2 3 4 5 and 1 2 3 4 5. So 5 into 5 matrix, this is a 5 into 5 matrix, so this is not a optimal one, so this is non-optimal, so we consider this as a non-optimal. We should do the improved matrix next step. In the next step we should do the improved matrix because it is a non-optimal matrix. If it seems to be equal, it is an optimal matrix, so we have to do improved matrix. Put head as improved matrix. In this step we should copy the elements which are present in this box. See this column, put the elements which are cutted by a single line. See the elements, here is 10 here, so we should put 10 here because it is cutted by a single line. So this 0 was also cutted by a single line, so we should put 0 here. Then see this element was also cutted by a single line, so you should put 10. This element also cutted by a single line, so we should put 5 here. See this element, it was already cutted by two lines, so you should not put this element. Next, moving on to this element, it was also cutted by a single element, so you should put 0 here. This element was also cutted by a single line, so you should put 0 here. See this, it was already cutted by 2 lines, so you should not put this, and this also, it also have 2 lines, so you should not put this elements in this box. This we should write this element in this box, this also, and this also, this also. In this column 25, 70, 0 and 7. Next step is we should look these elements which are not cutted by any lines. So in this in these elements we should find out which number is lower. Here we have 4 as the lower one, so mark this. You should do with this 4. Using this element, we should subtract each element with this 4. So 10 minus 4 is 6, 14 minus 4 is 10, 12 minus 4 is 8, 25 minus 4 is 21, 12 minus 4 is 8, 19 minus 4 is 15. 6 minus 4 is 2. 4 minus 4 is nothing but 0. So like this way you should do. Next thing is we should look into the 2-line cutting elements, that is 2, 5, 7. So in this element we should add this element with 2, sorry, with 4. So 2 plus 4 is 6 and 5 plus 4 is 9. 7 plus 4 is 11. In this way this box has been filled. Moving on to next step. Next step is allocation. See the row, it has only 1 0, so allocate this and cut the proportionate column. Next rows we have only 1 0, so allocate this and cut down the proportionate column. Next row we have only 1 0, so you should cut down the proportionate column. Next row we have only 1 0 in this row, so you should cut down the respective column. Next we have only 1 0, so you should allocate this and cut down the proportionate column. So we have 1 2 3 4 5. 1 2 3 4 5. So 5 allocation and that equal to the order of matrix. So you have optimal solution. So this seems to be a optimal because it has 5 is equal to 5 order, 5 allocation and equal to 5 the order of 5. So you should have the solution as a optimal one. Finally, you should put optimal assignment as a head, batsman, batting position and average runs scored. To fill this table, you should look the allocated cells. So in the first row and the last column, this allocation is present. So look at this 50. So you put 50 here. Look on to the next allocation. Here we have 42. So you should put 42 here. Then moving on to next allocation, in the third row, fourth column, we have allocated cells. So look at this. Here we have 60. So you put 60 here. And here we have 0 as a allocated cell in this row. So you should put 20 here. Moving on to next row, we have allocation in this cell. So you should put 60 here. We have 60 here. So you should put 60 here. So add all the amounts. The total is 232. So expected maximum total run is 232. In this way we should calculate this optimal assignment. For our super subscribers, I have summary for you to understand clearly and make it more easier. And the summary is, first you should copy the elements in this box and move to the next step. You should put relative loss matrix as a head, find which number is greater and subtract each element from that, and put row operation matrix as a head and see which row each row, and you should find lower number in each row and subtract that lower number from every elements and see next column wise. You should find out which number is lower and subtract every elements with that lower number. So then we have to allocate each row and see column wise. You should allocate each columns as allocated cells, and you should put improved matrix, find out which run is suitable for you, and you should understand it clearly. You can easily rock it. So you should we should keen in doing this improved matrix. You should analyze which elements are cutted by a single line and which elements are cutted by double lines and which elements are not cutted by any lines. So you should watch it clearly and you put optimal assignment as a head, and in the question you should take the elements and present this. Okay, average run scored. So you should add all the amounts and the total came. So expected maximum total runs is nothing but the answer. Okay, like, share and subscribe our channel to receive more videos like this, and share with your friends. Keep growing. Bye bye.